For the next step, we'll create the red handles shown here. And so turn off the canvas, and I'm going to hide the components except for the first component, and I'm going to turn on the visibility of that first sketch, and I'll hide this body, and then I'll create a new component. So I'll say create component, and I'm going to call this handle dash anvil cover. And then I'll make sure that's the active component, and I'll start a new sketch on the XY plane of that component, and then I'll P for project, and I'll project this line into my new sketch, and then I'll hide the sketches from the handle. And I'm going to then draw a line or a rectangle from the end of this, and I'll bring this over about like that. I'm then going to do another line, and I'll do it parallel to this line or horizontal, and I'll come down vertically, and we'll put a vertical line over here on this side, and we'll put some dimensions on here. So I'll dimension the distance from here to the origin, a distance of 1.265. I will dimension the length of this line as 6.205. I will dimension the distance from this line horizontally to the origin as 1 inch, and I'll dimension the length of this line as, actually rather than dimension the length of that, so let me undo on that. I'm going to put that relative to this line. So I'll dimension the distance from this line to this point, and let's do that as 0.17. And I will dimension this end as 0.45. And then I'm going to draw a line in here at an angle about like this, and then I'm going to click and drag an arc up to this end point. I will dimension length of this line, the aligned length, as 3.5, and I will dimension the radius of this arc as 5.75, and I will dimension the angle between this line and this line as 1.5 degrees. I will then drag this endpoint back a little ways if I can get it. I'll drag this endpoint back this way, and then I'm going to do a tangent arc from here up to here. So I'll do a tangent arc from the end of this line up to this line, and so I wanted it tangent to that line, so I started with that line, and then I'll put the dimension in here. The radius of this arc is 2.5. So this portion of the sketch is fully defined. I have an arc here. I'm going to make this line tangent to that arc, so I'll do tangent. This line is tangent to that arc. Then I'm going to drag this point over to, I'm trying to get it to snap to the end of that line. If it doesn't snap and make that black, then just do a coincident between this point and this projected point. Okay, our sketch is fully constrained, and so we're ready to create some geometry. So I'm going to finish this sketch, and I'll do extrude, and I'm going to select this area of the profile, and I'll also select this area of the profile, and we'll set this to be symmetric, total distance of 0.5, and we'll select this edge. We'll do a fillet on this edge and the corresponding edge on the other side of 0.15. Let's make those 0.125. So I'll do 0.125, and then I'll select this edge and I'll do a fillet, and it will go all the way around. Do that as 0.15. I'll then make that sketch visible again, so I'll go down and I'll make the sketch visible, and I'll do extrude again. This time I want to get that area inside there, so I'll do a long left click. I'll get profile. I'll get this profile, and if I want to be sure if I make any changes to this in the future, I'm also going to select this area in here and this area in here, and then I'll put that to do symmetric, and I'm going to do a total distance of 0.125 to cut this slot in here. So there's no clearance now between this slot and the handle. This handle is over molded over the metal part. We'll hide our sketch, and then we'll change the color of this. We might also change the material of this, and let's see what kind of materials that we might have in the plastics. So I'll go into the plastics folder, and I think I'll make this a ABS plastic. I'm not sure which one I want to use, and I also want to change the color of it. So I'll go to the appearance, and I'll change the color of this, and again we'll go into the plastics, and I'm going to find a translucent plastic, and let's put this red on here, put that on that body, close that. And now if we turn on the visibility of the body, so there is our handle, the cover over top of this handle, and then we'll do the same thing for the movable handle. So let's turn off this one, we'll turn off this one, we'll turn on the handle lever, and I'm going to turn on the visibility of that first sketch, and we don't need to see the body, so I'll hide the body for the moment, and then we'll use this to generate our sketch for the cover for this side. Now I can't drag this sketch, and so I'll turn on the visibility of the body, and then I can drag this, and I'm going to drag this so that it more or less looks like it's horizontal. I might intentionally put it a little bit beyond horizontal so that I don't accidentally get a horizontal constraint on here that is unintended. And then I'm going to hide that body, and I will make sure that actually I need to create a new component. So I will create a new component, and I'm going to call this handle dash lever cover, and then we'll go down and we will do a new sketch on the XY plane, and I'm going to capture position this time so it doesn't move that handle, and then I'll do P for project, and I'm going to project this line, and then I'll turn off the previous component, the visibility. And before we do that though, let's turn the body back on, and then I'll turn off the component, and I'm going to draw a 3-point rectangle. So I'll create a rectangle, 3 points, and I want it to be parallel to this line, so I'll scrub along that line, and then I'll come up, and I'm going to do coincident this point to this end and this point to this end of the line. And for now, let's drag this up here higher, and then I'm going to draw a line out here, and I want it parallel to this line, and I want to draw a line over this way, and I either perpendicular to that line or parallel to this line, and I'll come up either perpendicular or parallel, and I will dimension the distance from here to here as 0.1875. I will dimension the distance from here to here, and I'm going to make this dimension a function of that dimension. So if I change this one, it will automatically change this dimension. I'll do the aligned length of this line as 0.5, and I will do the distance from, or the length of this line as the aligned length. Is there a right click aligned? Yeah, if you right click aligned, it then ensures that it's aligned without having to click in just the right place. I'll do that at 0.235, and I'm going to make this line coincident to this line, but before I do that, I want to put in the remaining geometry, and then I'll make that coincident. So I'm going to draw a line from here up like this, and then I'll click and drag an arc to the end of this line. Now I don't want this arc tangent to that line. It's almost tangent the way I did it. If it did put a tangent on there, I would have to delete that because I don't intend it a tangent. And I'll click and drag an arc off of this end, and this arc I want going the other way, so I'll just come out here in space and click like that, and then let's drag this up higher, and now I can drag this over to the end of that. I'll dimension this arc, and let's just go ahead and put in the dimensions, and then we'll go back and change those. So I'll dimension this arc, and I will put in a length for this line, and I want that as the aligned length, 2.485, and then I want an angle between here and either here or here. It doesn't matter which one, they're parallel, and I'll do that as 1.5. Okay, now that I have these dimensions in here, I'm going to now make this point coincident to this line. So I'll do coincident this point to this line, and it all turns black. And then I'm going to go in here and edit these dimensions to what I had intended. So to change this dimension to 9.235, and I'll change this dimension to 1.725. Let's rearrange some of our dimensions for clarity. Okay, so I've got this 1.5 angle. I've got the radius of this arc, the radius of this arc, and this distance, this offset distance. And then let's make this line tangent to the highest point on this is the tangent point of this arc. So I'll do tangent this line to this arc right here. If I go back and look at my canvas, so if I move that up some, so here is our shape for this side. I will then do an extrude, and so I'll go to solid, I'll do extrude, and I'm going to pick this profile and this profile. We will go symmetric, and we'll go a total distance of 0.5. I will turn on the visibility of that sketch so that we can use it again, and I'll do extrude again, and I will do a long left click. I'll get that profile, and again, I don't really have to get these two areas, but I might make a change that would result in something not acting with the behavior that I expect, so I'm going to get those two areas as well. And I'll go symmetric, and we'll do a total distance on this one of 0.4, and we'll say OK to that, and I'll hide that sketch. And then we will do a fillet on this corner and on this corner of 0.125, and then we'll do a fillet on this loop going around there at 0.15. We'll change our material, so I'll right click, I'll go to the material, and I'm going to drag this plastic onto this part, and I'll also go to the appearance, and I'll drag this appearance onto this part. We'll turn on the visibility of all of our components, and somewhere I have a sketch visible. I believe it's under the handle lever. Let's turn off that sketch. Okay, and when I drag this, I see that this part will move. It isn't constrained to this part, so let's undo that. In the same way with this one. So we'll select this part, and I'm going to hold the control key down, and I'll select this part, and I'll right click. I'm going to create a rigid group between those two parts. We'll say OK to that. And now if I drag this, we see that those move together. And I'll do the same thing up here. I'll select this part, and let's go up here and make this top level of the assembly active. And I'll select this part, I'll control select this part, and I'll make those a rigid group. And so now I have everything constrained, and if I have any extraneous capture positions down here, I'll delete those now that I have everything positioned, and I don't see any others. Check your timeline, make sure there are no yellow or red highlighted issues. Another thing you might do from time to time is go to Tools and select Compute All, or just hit Control B on Windows machine. I guess that's Command B on a Mac, and just to rebuild everything, make sure that there aren't any errors. So we have our assembly created, and then we can go around and investigate various considerations, make sure that we have clearance between components, and we may run into interference detection between various components. And let's go ahead and select a bunch of these components, and any interference that it shows me is, remember, this is scientific notation, so this is out to the -5 decimal places, essentially no interference, and that's just where those components, the pin is up against this edge, and we could increase the length of this pin by a small amount if desired. And then if we look at the motion of this, so if I come up, and the most force between the movable jaw and the stationary anvil, the press plate and the stationary anvil, will be when it's a straight line across these three pins. So if I move this up, that would be the maximum force right there, because if I start to move it up more, then it starts to go back. And so we might have, if we're designing this tool to crimp, say, a fastener onto electrical wire, we have this designed in such a way that it can only crimp it to a certain distance and it can crimp it no further. So we can't over crimp the component. But if we look at this, the way it's designed now, we'll have to make a couple of changes because there's some interference right here. So we need to edit this to move this slot up higher. And if we look at these plastic covers, the plastic covers are interfering with each other right here. So we need to edit the plastic covers. If I turn off those plastic covers, this part goes down inside of this part, so there's no interference issue there. It's only with the plastic covers. If I go to wireframe view, and so I'll come down here and I'll set the visual style to wireframe. We want to make sure that this pin right here, it looks like it's tangent to the bottom of the slot right there. And then if I drag it up this way, this will inhibit the amount of rotation that it will go that way. And we need to open far enough to get the wire connector in here, but we don't want to open up so far that the operator has to use two hands to get this handle together where they can then squeeze the handle. So we would want to make this slot the minimum distance that we can and still be able to get the fastener in here to crimp onto the wire. And then also we have to watch that where this little spot right in here, when I come up here, let's look at this, when I get this straight across. So when we could put in a constraint to make sure that we have that straight across, but we also need to make sure that there's no interference between here and here. So it looks like there's a little bit of interference, and so what we would have to do is either change this height here or just move this back a little bit, and I think that's what I would do. Just move this edge back a little bit. So examine your geometry, make sure that everything will work the way you expect it to work, and in the next set of steps we will look at running an analysis on this to get an unknown force. If we put our hand here, or we put our hand here, or we put it here and put in a certain amount of grip force, what is the force that we get over here at the working end of this tool? Now Fusion 360 doesn't have dynamic simulation tools to analyze that, so we'll take this part over into Autodesk Inventor Professional to run that analysis in that software.